Now in the question 13, Bernard has three pairs of headphones A, B, and C. In a year, the probability of headphones A, B, and C malfunctioning are 0.03, 0.12, and zero point 0.3 respectively. Find the probability that in a year in the part 1 all three pairs of headphones malfunction. So in the part 1 we have to find out all three malfunctions. So, since the probabilities of the headphones A, B, and C malfunctioning are given in the question, and those are 0.03, 0.12, and zero point 0.3 respectively. And here we will apply the multiplication law of probabilities. So 0.03 multiplied by 0.12 multiplied by zero point 0.3. Now here we will multiply 0.03 with 0.12. So here we have 3 twos is 6 and 2 zeros are 0 and 2 zeros are 0. Now here we have 1 threes are 3 and 1 zeros are 0 and 1 zeros are 0, and here we have all of zeros. Now answer will be 0, 0, 0, 3 and 6, so it will be 0.0036. Now we will multiply 0.0036 with 0.3. So we have 6 threes are 18, and here we have 1, 3 threes are 9 and 10. So here we have 1. No, 3 zeros are 0, and here we have 1. Again we have 3 zeros are 0 and 3 zeros are 0. Multiply by, here we have 1, 2, 3, 4 and 5 zeros. So 0, 0, 0, 1, 0 and 8. So here we have 0.0010 and 8. So after multiplication we will get 0.00108. So the probability that all three malfunctions is equals to 0.00108. Now we have to find out the probability in the part 2 in a year that all three pairs of headphones function properly. So for this, since the probabilities of malfunctioning are given and we want to find out the probabilities of functioning of the headphones, so we will just simply take away the probabilities of malfunctioning from one by one. So here we have 1 minus 0.03, and we have will apply the multiplication law of probabilities here, and here we have 1 minus 0.12 multiplied by 1 minus 0.3, and now we will one by one subtract the values from 1. So here we have 10 minus 3, 7, and here we have 9. So the answer is 0.97 multiplied by, now we have 1 minus 0.12. So here we have 8, and here we have 9, take away 1, 8 again. So here we have 0.88 multiplied by 1 minus 0.30. So here we have 10, take away 3, 7, and it will be 0.7. So now we have to multiply 0.97 with 0.88 and with 0.7. So first we will multiply this pair, 0.97 and 0.88. So here we have 8 sevens are 56, and here we have 5. 72 add 5 is 77, and 8 zeros are 0, so here we have 7 multiplied by 8 sevens are 56, sorry, we have 5. Again we have 77, and here we have 7. Again we have 7, and now we have 1, 2, and 3 zeros. We have 6. Here we have 13, 14, and here we have 5, 1, 8, and here we have 0. So here we have 0.8536. Now after multiplying 0.88 with 0.7, we get 0.616, and after multiplying 0.97 with 0.616, we get 0.59. After multiplying 0.97 with 0.616, we get 0.59752. So the probability that all three function properly is equals to 0.59752. Now in the part 3, we have to find out the probability that at least one pair of headphones malfunction. So for the probability that at least one pair malfunction, we have to just subtract the probability of all three function properly from 1. And since we have find out the probability in the part 2 for the all three functions properly, and that was 0.59752, now we will take away 0.59752 from 1. So here we have 10 take away 2, 8, 9 take away 5, 4, 9 take away 7 is 2, 9 take away 9 is 0, 9 take away 5 is 4, and here we have 0 take away 0 is 0. So the answer is 0.40248. So the probability that at least one pair of functions will be equals to 0.40248. Now in the part 4, we have to find out the probability that in a year exactly two pairs of headphones malfunction. So for this we have three possibilities. The first possibility is probability for only A and B malfunction. So it means C works properly, C functions properly, plus the probability only B and C malfunctions. Similarly, probability that only A and C malfunction. Now we will apply the multiplication law of probabilities here. So the probability that A and B malfunctions, so it means C functions properly. So the probability for only A and B malfunctions, so the probability for function A malfunctionality is 0.03 multiplied by 4B, that is 0.12. Now here we have 0.7 for the headphone C. Now only for B and C. For A we have 0.97 multiplied by, for B is given, that is 0.12, and we have 0.3 plus, now we have for A 0.03, for B 0.88. Headphone pair of headphones B functions properly, and for malfunctionality of the pair of headphones C, and that is given, and that is 0.3. Now further we have 0.3 0.03 multiplied by, when we multiply 0.12 with 0.7, we will get 0.084 plus 0.97 multiplied by, when we multiply 0.12 with 0.3, we will get 0.036 plus 0.03 multiplied by, now when 0.88 multiplied with 0.3, so here we have 0.064. Now after multiplying the following terms, we will get 0.00252 plus 0.03492 plus 0.00192. So now we will add up these three values. So 3 times 2 is 6, 9 9s 9 9 18. So we have 23, carry 2, 4 1 5 6 7 8 9. Here we have 9, and here we have 3, and here we have 0, and again 0. So the answer is 0.03 936. So the probability that exactly two pairs malfunction is equals to 0.03936. Now we have here 0.264, and here we have 0.00792, and here again we have 792. Now 7 add 2 is 9, 10, 11, 13, 14, 15, and 16. So here we have 6 add 1. Here we have 3 and 4. Now after multiplication, we will get 0.00252 plus 0.03492 plus 0.00792, and after adding up, we will get 0.04536. So the probability that exactly two pairs malfunction will be equals to 0.04536. Now in the question 14, in a wardrobe there are 16 shirts, of which 8 are black, 6 are white, and 2 are blue. The shirts are identical except for their color. In the part 1, if two shirts are taken out of the wardrobe at random, find the probability that in the part A both are black. Since total shirts equals to 16, black shirts equals to 8, white shirts equals to 6, and blue shirts equals to 2. So for the probability that bought black, first we have to find out the probability for the black shirt first. So, and it is also given that we have to take in two shirts from the wardrobe at random. So for the probability for the first black shirt will be, total number of outcomes is 16, and favorable outcomes in the case of black shirt is 8. So here we have 8 over 16. Now for the second shirt to be black, we have the probability, since we have already taken one shirt, so the total number of shirts will remain 15, and also we have taken one shirt, one black shirt already, so the number of black shirts will remain, that left is 7. So the probability for the second shirt to be black will be 7 over 15. So now By simplification, we will get 2 4s are 8 and 2 8s are 16, and after further simplification, we will get 2 2s are 4 and 2 4s are 8, and further simplification gives us 1 over 2. So 1 over 2 multiplied by 7 over 15, and after multiplication we will get 7 over 30. So the probability that both black is equals to 7 over 30. Now in the part 2b, we have to find out the probability that one shirt is black and the other is white. So here we have two possibilities. The first possibility is the first is white plus the probability of the first is white and the second is black plus the probability first is black and second is white. And second is white. So since we have know the probability for the black shirt, that was 8 over 16. Now for the blue shirt, for the black shirt we have 8 over 16. Now for the white shirt we have the probability 6 over 16. So now for the probability that the first is white, so we will write down here 8 over 16 multiply by second is black. Second is black. So since we have already choose one black shirt, so the 15 shirts are left, and since we have to select the two shirts, so the number of white shirts are 6, so here we will have 6 over 15 plus, now the first shirt is black, now the first shirt is white, so here we have the probability 6 over 16 multiplied by, since we have already chosen one shirt, so 15 shirts are left, and from black we have 8 over 15. So here we have 2 4s are 8 and 2 8s are 16. Further simplification gives us 2 over 4, and further simplification gives us 1 over 2. So here we have 1 over 2 multiplied by 6 over 15 plus 2 3s are 6 and 2 8s are 16, and from this with 8 cancel with 8. So here we have 3 over 15, and here after cancellation we will also get 3 over 15. So 3 over 15 plus 3 over 15 will be equals to 6 over 15. So the probability that one black and one white is equals to 6 over 15. And further simplification gives us 2 3s are 6 and 2 5s are 15. 3 2s are 6 and 3 5s are 15. So it will be equal to 2 over 5. So the probability that one black and one white is equals to 2 over 50, 2 over 5. Now in the question 1. Now in the question 14, part 1C. We have to find out the probability that the two shirts are of the same color. So for this, since we have three colors, black, white, since we have the three colors black, white and blue, so here we have three possibilities. The probability that both black plus probability that both white plus probability that both blue. Since the probability for the first shirt to be black is number of favorable outcomes divided by number of total outcomes, so 8 over 16. Since number of black shirts is 8 and total shirts are 16, so probability that first shirt to be black will be 8 over 16. Since we have already taken one shirt from the total shirts, so 15 shirts are left. And since we have already chosen one shirt from the black shirt, so 7 black shirts are left. So the probability for the second shirt to be black is 7 over 15. Now plus probability for the first shirt to be black, to be white, probability for the first shirt to be white will be 6 over 16. And for the second shirt, since we have already taken one shirt, so 5 white shirts are left and total number of shirts left are 15, so here we have 5 over 15 plus. Now the first shirt to be blue, the probability will be 2 over 16, and since we have already taken one white shirt, so the one blue shirt will be left, so the probability for the second shirt to be blue will be 1 over 15. Now we will simplify. Here we have 1 over 2, and here we have 3 over 8, and here we have 1 over 3. After simplifications further, here we have 1 over 8. So now we have 7 over 30 plus 3 over 24 plus 1 over 120. Now we will take the LCM of 30, 24 and 120. So 2 ones are 2 and 2 5s are 10. 2 ones are 2 and 2 to the 4. 2 6 are 12. Here is 60. Now we have 2 4s are 2 6 are 12, and here we have 2 3s are 6. 3 over 24 plus 1 over 20. So we can further simplify 3 over 24. So here we have 1 over 8. Now we will take the LCM of now after simplification we have got 7 over 30 plus 1 over 8 plus 1 over 20. So we will take the LCM of 38 and 120. So from the two ones are 2 and 2 5s are 10 and 2 4s are 8. So we have 2 6 are 12, 2 2s are 4 and 2 3s are 6, and now we have 3. So here we have 3 5s are 15 and 3 10s are 30. Now we have 2. So here we have 5. 2 1s are 2. 2 5s are 10. So 5 2s are 10 and 10 3s are 30 and 30 2s are 60 and 62 are 120, so the LCM will be 120. Since 121s are 120, so here we have 1 plus 30 multiplied by 4. So 34s are 120, so 7 multiplied by 4 plus जैन मेरे पास भी नहीं चुप कर रहा था, मैंने कहा शायद मामा के पास हो जाए. Now since 8 ones are 8, so 12 take away 8 is 1 2 3 40, and here we have 5 15. So here we have 1 multiplied by 15. No. Now we have 7 4s are 28 plus 15 plus 1 over 120. When we add 28 and 16, so here we have 8 14 and 1 44. So here we have 44 over 120. Now further simplification gives us 22 over 60, and more simplifications will give us 11 over 30, so it will be equals to 11 over 30. So the probability that both are same color is equals to 11 over 30. Now if a third shirt is taken out from the wardrobe at random, calculate the probability that all three shirts are black. So since for the first shirt to be black, the probability is 8 over 16. Since we have already taken out one shirt from the black shirt and total shirts are left are 15, so here we have 7 over 15. Since we have already chosen two shirts from the total shirts, so the total shirts are left are 14, and since we have already taken two shirts from the black shirts, so the 6 black shirts are left. Now since we have further simplifications, so here we have 1 over 2, here we have 3 over 7, and this 7 cancel out with 7, so here we have 3 over 30, and it will also give us further simplifications 1 over 10. So the probability that all three are black will be equals to 1 over 10. Now question 15. Box A contains 7 blue balls and 5 yellow balls. Box B contains 3 blue balls and 7 yellow balls. One ball is removed at random from box A and placed into box B. After thoroughly mixing the balls, a ball is drawn at random from box B and placed back into box A. In the part 1, draw a tree diagram to show the probabilities of the possible outcomes. So here we will have use two alphabets B and Y. B is for blue and Y is for yellow. So now ball drawn from box A to box B. So here we have two possibilities. First is blue and the second is Y. Since the total number of balls will be 7 blue balls and 5 yellow balls, so it will be 12. And since the number of blue balls is 7, so the probability for the blue ball drawn from box A to box B will be 7 over 12, and for the yellow ball it will be 5 over 12. Now we have further 4 possibilities. Ball drawn from box B to box A. Here we have B and Y, B and Y. Since in the statement we have read that after thoroughly mixing balls, a ball is drawn at random from box B and placed back into the box A. So when one ball taken from the box A placed back into the box A, so the number of blue balls, since one ball is already removed from the box A, so the total number of balls that are left will be 11. And since in the box B there were 3 blue balls, and when we placed one ball back into the box A, so the total number of blue balls will become 4. So here we have the probability 4 over 11, and for the case of yellow balls we have 7 over 11. Now for the blue balls, since in the box B we have 3 blue balls and 7 yellow balls, so and also a box, after a ball is drawn at random from box B and placed back into a box A, so since one ball is put back into the box, so the number of blue balls will become 4. So the probability for the blue ball drawn from box B to box A will be 4 over 11, and since the number of balls in the box B is 7, so the probability for the yellow ball will be 7 over 11. Now, and since the number of blue balls in the box B is 3, and since there are 7 yellow balls in the box B, but since a ball is drawn back into the box A, so the total number of yellow balls will become 8, and the probability for the yellow ball drawn from box B to box A will be 8 over 11. So this is the required tree diagram showing the possibilities of the probabilities of the possible outcomes. Now in the question 15 part 2a, find the probability that at the end of the experiment box A has more yellow balls than blue balls. Since the number of blue balls is 7 and the number of yellow balls is 5, so this is an impossible event. So the probability that more yellow balls than blue balls will be equals to 0. Now in the part B, find the probability that box A contains exactly 7 blue and 5 yellow balls. So for this we have two possibilities, that the first ball is blue, the second ball is also blue, plus the probability of both balls are yellow. So for this, from the tree diagram, ball drawn from box A to box B, then the probability for the blue ball is 7 over 12, and multiply by from box B to box A, it is 4 over 11 plus. Now when the yellow ball is drawn from box A to box B, the probability is 5 over 12 multiply by, now the probability for the yellow ball drawn from box B to box A is 8 over 11. So now we will simplify the terms. So 4 3 is a 12, and here we have a 2 4s are 8 and 2 6 are 12, and further we can simplify it. So we have 2 to the 4 and 2 3 is a 6. So here we have 7 over 33 plus 10 over 33. Now we will add this. Then we have 7 plus 10 over 33. And after adding up, it will become 17 over 33. So the probability that box A has exactly 7 blue and 5 yellow balls is equals to 17 over 33. Now in the part 2C, we have to find out the probability that box A has twice as many blue balls as yellow balls. So here we have probability of YB, and from the tree diagram we will apply the multiplication law of probabilities here. So the probability that a yellow ball drawn from box A to B will be 5 over 12 multiplied by, now the probability that the blue ball drawn from the box B to A is 3 over 11. Now we have 5 3s are 15, and 12 multiplied by 11 gives us 122. So now the probability that twice as many blue balls as yellow ball is equals to 15 over 122. And after multiplication we will get 5 3s are 15 and 12 11s are 132. And after simplification we will get, with the table of 3, it will be gives us 5 over 44. So the probability that box A has twice as many blue balls as yellow balls will be equals to 5 over 44.